Okay, this is the last video for Chapter 3. This is just a bunch of derivatives of trigonometric functions. So we've explored these graphically before, and hopefully you guys have noticed that as you take the derivative of a sine curve, you end up with a cosine curve. So the derivative of sine of x is cosine of x. The derivative of cosine x, and here you're going to learn that the derivative of any of these cofunctions is opposite, okay, and it's negative. So we're going to have negative, and then it'll go back to sine x. Now that only works for this first pair. The other two will be negative, but it's different. So the derivative of tangent of x is secant squared of x. And again, they get these from turning this into sine over cosine and doing a quotient rule. We're going to skip all that because this is just kind of a reference guide. Cotangent, derivative of cotangent becomes negative cosecant squared of x. The derivative of secant is secant x times tangent x. And finally, the derivative of cosecant x is negative cosecant x times cotangent x. Again, notice how all the derivative of the cofunctions are negative. Alright, so we're going to use that information to just do some derivatives. First one, find the derivatives of x squared sine of x and cosine of x over 1 minus sine of x. First things first, you should note in part A that this is a product rule. Okay, so that means you take the derivative of the first times the second plus the derivative of the second times the first. So y prime is equal to the derivative of the first, which is 2x, times the second, which is sine of x. And then product rule is a plus. We leave this the same. And actually, it really doesn't matter what order you do a product rule in, because it's a plus. So you can do the derivative of the second first and keep the first the same. It really doesn't matter. Times the derivative of the second, which is cosine of x. And that's the answer. There it is. So you can just rewrite it as y prime equals 2x sine of x plus x squared cosine of x, or rewrite it, in descending order. All right, this one here is a quotient rule. So for part B, u prime is equal to, and actually maybe I should just say du dx. That really doesn't matter. All right, is quotient rule because you're dividing. Remember, it's low times the derivative of the high minus high derivative of the low over the square of what's below. So it's going to be low 1 minus sine of x times the derivative of cosine of x, which is negative sine of x, minus cosine of x times the derivative of this. Derivative of 1 is 0. The derivative of negative sine of x becomes negative cosine of x because sine of x is cosine of x. So negative cosine of x all over 1 minus sine x squared. Alright, let's see how this simplifies. We get down here, we get negative sine of x plus sine squared minus, or actually it'll become a plus cosine squared all over 1 minus sine squared, or sine of x squared. Okay, and then what happens with that is, hopefully you guys remember your trig identity, the main one. Sine squared plus cosine squared equals a 1. So we get 1 minus sine of x on top all over a 1 minus sine x squared. And since there's a 1 minus sine x on top and a 1 minus sine x on bottom, it just becomes 1 over 1 minus sine of x. So that is how you take the derivative of that one using the quotient rule. Alright, another thing to learn is jerk, which is a sudden change in acceleration. Okay, basically the derivative of acceleration. So for part A, it just says find the jerk caused by gravity. Well, hopefully you guys remember that gravity has a constant acceleration. It doesn't change. If it's in feet per second, it's negative 32 feet per second squared. Okay? That means it's pulling us towards the Earth, the negative. So if we take the derivative of that, so A prime, which is equal to the jerk, is just equal to 0. Which is a good thing, because if the acceleration on Earth was changing, you would be getting sick just sitting around. That, you know what motion sickness is caused by? By jerk, change in acceleration. That's why people get sick in cars. So this is why we don't experience motion sickness. I guess unless you have vertigo, but that's a whole different problem. Sitting around. But just from gravity, we don't experience motion sickness. It would be terrible if we did, if the gravity kept changing while we were just sitting there. So find the jerk if the position is 2 sine t. So with these are basically, it's going to be called simple harmonic motion. It just means that the object just oscillates back and forth and keeps the same motion for eternity, like it doesn't slow down or anything. So you usually see that with these kind of equations. So this is just a basic question though. So the velocity is the derivative of that, which is 2 derivative of sine t is cosine t. The acceleration then is the derivative of this. 2 times derivative of cosine t is negative sine t, which means it's just negative 2 sine t. And finally the jerk is equal to negative 2 derivative of sine t is cosine of t. So let's analyze this. The position and the acceleration are actually the same except for opposite signs. So when one's acting in one direction, or you're moving in one direction, the other's acting in the other. And then for velocity and jerk, same thing. Okay? Alright, this is just a random problem to kind of review how to come up with equations that are tangent to normal the graph of tangent of x over x. Now, this one you can do by hand, but because it's telling you to evaluate at x equals 2, since tangent of 2 is not exact, we're going to use our calculator. Remember, it depends on which system you have, but remember you go to Math, and you go all the way down to, let's see, n-deriv, which is number 8. And if you have this format, it'll just show up like this. So we want to know the derivative with respect to x of tan x. So I'm going to hit alpha y equal n, tangent of x over x. Let me also make sure my mode is in radians, which it is. Good. And then I want to evaluate that when x is equal to 2. And this should give us the slope, because again, the derivative is the slope, and the slope at that point, well, we don't know the full point yet. We have to actually figure that out too. When x equals 2 is 3.433. So 3.433. So again, n-deriv, which is math 8, I think it was. I don't want to tell you the wrong thing now. I believe it was 8 though. Yes. Okay. So math 8, and then you get that. Now, if you have the other older operating system, you would type it in like this. You just type in the function, comma, the variable you used, and then what number you want to evaluate that variable at. That's how you would type it in. And we get 3.433, which is equal to the slope. We also need the y-coordinate to write our equation. We know x is 2, so y is equal to tangent of 2 over 2. Type that in, and you get negative 1.093. Alright, so now we have our point. It's 2 comma negative 1.093, and the slope is 3.433. So my tangent line has an equation of y opposite of the y-coordinate is equal to the slope times x minus the x coordinate. And we can just leave it like that. And if you flip this and change the sign, you get the normal equation. Is y, and the point's the same. The slope becomes negative 0.291 times x minus 2. Okay, so again, just something to practice. You could do this by hand and then plug it in, but for this I wanted to actually show the calculator for once, because we'll do a lot more of these later. Find y double prime if y equals secant of x. So this is doing a double derivative. So the first derivative, y prime, is equal to the derivative of secant, which is secant tangent. So secant of x times tangent of x. Now, if I want to take the derivative of this, I now have a product rule situation. So that means y double prime is equal to the derivative of the first, which is secant x times tangent of x, times the same of the second, or keep the second the same, plus keep the first the same, times the derivative of tangent, which is secant squared. Okay? Finally, just combine things and you get the y double prime is equal to secant cubed of x plus secant x tan squared of x. And actually, if you... No, that's where we're at. Okay. And then finally, we're going to just... I talked about simple harmonic motion. I'm just going to get right into it. So there's a weight hanging from a spring stretched 5 units beyond its rest position. So that would be positive 5 is stretching away from the ceiling. And then released at time t0, which is right here, to bob up and down. Its position at any later time is modeled by position 5 cosine of t. What are the velocity and acceleration at time t? So first step, we're going to find the velocity at t, which is just the derivative. So it's 5 times the derivative of cosine, which is negative sine of t, or negative 5 sine of t. And the other thing is acceleration, which is the derivative of this. So it's negative 5 times the derivative of sine, which is cosine. So we get negative 5 cosine of t. Okay, so here's what's happening. The weight is oscillating. And you can look at this on a graph if you want, or plug in values for t. So at 0, we know that the position is 5 when you plug in a 0 for t, because cosine of 0 is 1. We know the acceleration is negative 5, which makes sense, because if you're here, the spring is pulling it back towards in the negative direction towards the ceiling, and the acceleration is going to be greatest here. However, is it moving here when we're holding it in place? No, and that's why when you put a 0 in for sine of t, that becomes 0. So in general, the weight oscillates between, so I'm just generally saying what the position is doing, negative 5 and 5 units, which gives you a curve of an amplitude is 5 and a period of 2 pi. It'll come back to the same place every 2 pi. The velocity is at a max when the position is 0. Because think about it. The weight is not moving at the top or the bottom because it's changing directions. So it has to be moving its fastest right in the middle. And also, if you think about a curve, the slope is the fastest on a sine or cosine curve right in the middle, not at its crest or trough. So velocity is at a max when position is 0. And then it's also speed and velocity are 0 when the position is equal to plus or minus 5 units. So it's not moving at those spots. And then finally we can say that the acceleration is the exact opposite opposite of position. So again, it's max when it's at either the top or bottom because the spring's pushing it in the other direction or pulling it, and then it's 0 when you're at a 0 rest position because the spring and the weight cancel each other out. So, okay, so that's kind of what harmonic motion is. It's just it's a thing that it's modeled by a sine or cosine curve, sinusoid, and keeps going. So, all right, that is sine, cosine, tangent, secant, cosecant, cotangent derivatives.